Hello class, welcome to today's lesson, which is 2.5 factoring of addition and difference of cubes. Okay, this is the next type of expressions that we're going to try to factorize. Remember that the stage 2 is all about factoring. Okay, stage 2 factoring, stage 1 operations with polynomials. You have to understand what we're doing in every single stage. Okay, so let's begin. First, let me remind you very quickly that we already know how to factorize something like this, for example. Okay, remember that this is a difference of squares, and we have a formula to factorize something like this. What we do is first put these two numbers as the square of something. For example, 4x squared is the square of 2x, 9y to the square is the square of 3y, and we can go directly to the formula, right? The formula for the factorization of a difference of squares is the product of two conjugated binomials, in this case formed by these two terms, 2x minus 3y times 2x plus 3y. So we have a formula to factorize a difference of squares into the product of conjugated binomials. We got that covered. What else do we know how to factorize? We also know how to factorize a perfect square trinomial like this. 4x squared plus 4x plus 1. You know, there was something to be done over here, a couple of steps. Okay, step 1, making sure that this and this can be written as squares. And number 2, making sure that this term is twice the product of those two numbers, right? I mean, not this and this, but the numbers to which, let me write down these two numbers, right? The numbers such that raised to the square give you this term and this term. Okay, and we can also write down the factorization. Okay, now we're gonna discover another formula for factorizing an addition and a difference of cubes. So in this case, we're gonna be able to also factorize the addition, because in the example that I gave you here, we only know how to factorize the difference of squares. But in this case, it's going to be both the addition and the difference of cubes. Okay, for example, we're going to be able how to factorize something like this: 4x to the cube plus y to the, I'm sorry, 8 8x to the cube plus y to the cube. We're going to be able to know how to factorize this. So what is the formula for factorizing a difference or an addition of cubes? Some people discovered some time ago, a long time ago, that when you multiply these two factors, x plus y times x squared minus xy plus y squared, we have two factors. This is one factor, this is the other factor. We're multiplying them together. And when they look like this, exactly like x plus y times x squared minus xy plus y squared, when the shape of the factors are exactly like this, what you get as a result is the following. Let's do it. X times x squared, you get x to the cube. X times minus xy, you get minus x squared y, plus y times plus y squared, you get plus y to the cube. And then, no, I'm sorry, I made a mistake in there. I skipped this one. X times y squared. So you get x y squared. And we are done with the x. Now let's go with the y. Y times x squared, you get plus x squared y. I'm changing the order. Y times minus xy, you get minus xy squared. And then plus y times plus y squared, that's going to give you plus y to the cube. When you collect like terms in all of this expression, you're gonna see that this term and this term add up to 0, right? And this other term and this other term also add up to 0. And the final result of all of this will be simply x to the cube plus y to the cube. So in the end, by multiplying these two factors, this factor and this factor, we get x to the cube plus y to the cube. And we may as well erase all of this process. We don't need it anymore. Let me tell you why. Okay, what we have found by accident, well, what some people found out by accident is that by multiplying these two specific factors, this and this, you get an addition of cubes. You see? And by doing this, guys, you already get automatically, or as a bonus, you get a formula for factorizing an addition of cubes. Is this an addition of cubes? Yes. And it can be factorized in this way. Okay. Again, what is the correct? Maybe what is the correct way to read? Let me write it down backwards. The addition of cubes is equal to the sum of the two numbers. Okay. Let's read it this way. One number to the cube plus a second number to the cube is equal to the sum of the numbers times the first number, you see, to the square, according to my formula, minus the product of these two numbers, the first and the second, plus the square of the second number. So this is my first number, this is my second number. First number to the cube plus second number to the cube. That's equal to the sum of the first plus the second times the first to the square minus the product of both of them plus the square of the second number. And that is my formula. This is the formula that we're going to use to factorize an addition of cubes. And let's put it to use right away. Suppose that I give you this problem. X to the cube plus y to the cube, and the problem is factorize this difference of cubes. Now first, how do I make sure that this is in fact a difference of cubes? Okay, I'm sorry, an addition of cubes. I'm sorry, this is obviously an addition. How do I make sure of that? Okay, you have to be able to write this number as the cube of something and this other number as the cube of something, okay, in order to say that all of this expression is in fact an addition of cubes. If you cannot express this number as the cube of something and this number as the cube of something, you're not talking about addition of cubes. So x to the cube is the cube of x. That's quite simple, right? And 8y to the cube will be the cube of 2y, because 2y to the cube is equal to 8y to the cube. Why? Because we elevate the 2 to the cube. That's 2 times 2 times 2, which is 8. And also y to the cube, which is clearly y to the cube. So this is in fact an addition of cubes, and we can proceed to use our formula in order to factorize this addition of cubes, which is the same as this, right? So let's start. What does my formula say? My formula says, okay, all of this will be the product of two factors, one longer than the other. This one's going to be a binomial, this one's going to be a trinomial. What's going to be this binomial? It's going to be my first number plus my second number. And by first number, I mean this, and by second number, I mean this. So let's write them down. X plus 2y. And then we're going to have a trinomial. What's going to be the first term in the trinomial? My first number to the square. What is my first number? It's x. So I just write x to the square minus the product of the first number times the second What is my first number is x. What is my second number is 2y. So I can do this. That's perfectly okay. And finally, we have a plus second number to the square. What is my second number? Is 2y, and I square all of these. So I'm gonna get 4y squared, and I'm done. This is my full solution. Now, if you want to write it down in a better way, it would be that like this. Like you actually bring this coefficient to the very beginning of that term. So it's gonna look like this: minus 2xy plus 4y squared, barely fitting right there. Okay, and this also would be correct. Both of these things are the same, clearly. Okay, so that's how it works for addition of cubes. We have this formula that you have to memorize. Okay, and the best way you can memorize this or remember it or reading it is if I have some first number to the cube plus a second number to the cube, the factorization of this expression, which is an addition of cubes, will be the sum of both the first plus the second times the first to the square minus the product of the first times the second plus the square of the second number. That's how you do it. Okay, now let's look at the difference of cubes. It's going to be very similar. If you understood this, you will not have any problems with the difference of cubes. In a very similar way, some people discovered that by multiplying these two factors in this precise order with these precise signs and so on, by multiplying these two factors, you will get as the result, just like I did before, you're gonna get this. Okay, you can trust me on this, or you can work out the whole thing and make sure that the product of these two factors will give you this difference of cubes. Okay, so now you have a formula for the factorization of a difference of cubes, which is the first number minus the second number times the first number to the square. I'm sorry, I made a mistake in here. It's a plus. I'm so sorry about that. Okay, plus the product of both numbers, the first and the second, plus the second number to the square. So this is the formula that we're gonna use to factorize differences of cubes. And let's work out an example. For example, what if I give you 8x to the cube minus, so that is a difference, minus 27y to the cube. Okay, so this apparently looks like a difference of cubes. How do I make sure? I try to put this number and this number as the cube of something and the cube of something. Okay, so what's going to be that number such that to the cube gives me 8x to the cube? That's going to be 2x. And what's going to be this number such that raised to the cube will give me all of this? That's going to be that's going to be 3y, because 3 to the cube is 27, and because y to the cube is obviously y to the cube, and the minus stays. So this is, in fact, now we have put this into a perfect difference of cubes. This is the difference of the cube of this and the cube of this, and we can use now the formula just as is. So first, I write my two polynomials. This one is gonna be a binomial. This one's gonna be a trinomial. The binomial consists of the difference of the first minus the second. What is my first number? It's 2x minus my second number, which is 3y. And then comes all of this, my first number to the square. So this is my first number and I'm gonna square it. So it's gonna be 4x squared. Then we have a plus the product of both numbers, the first times the second. So the product of this and the product of this, I'm gonna do it automatically. That's gonna be 6xy, right? And finally, we have another plus and my second number to the square. This is my second number. I square it. I get 9y to the square, and I'm done. Problem solved. All of this, which is obviously the same as all of this, can be written in this factorized form. Okay, so that's how this works, guys. You have to memorize these two formulas, this one and the previous one about the addition of cubes. They are a little harder to memorize because you have to pay attention to the signs. The terms all look the same. It's x, y, x squared, xy, and y squared. The only thing that changes is this sign and this sign. And that could be a source of confusion. So memorize the placing of the signs. That's the only tricky thing in this lesson. Okay, guys, so I think that with these two problems or these two examples, you should be able to work out through the workbook. And if you have questions, ask me. Thank you, guys.